Namespaces are used to avoid naming conflicts by allowing entities, such as classes and functions, to be grouped under a separate scope. In the example shown here, there are two classes that belong to the global scope. Since both classes share the same name and scope, the code will not compile. One way to solve this problem would be to rename one of the conflicting classes. Another solution is to group one or both of them under a different namespace, by enclosing each in a namespace block. The classes then belong to different scopes, and so will no longer cause a naming conflict. To access a member of a namespace from the outside, the member's fully qualified name needs to be specified. This means that the member name has to be prefixed with the namespace it belongs to, followed by the scope resolution operator. It is possible to nest namespaces any number of levels deep, to further structure the program entities. Just ensure that the nested namespace members are qualified with the full namespace hierarchy when using them from another namespace. To avoid having to specify the namespace every time one of its members is used, the namespace can be imported with the help of a using declaration. This declaration includes the using namespace keywords, followed by the namespace to be imported. It can be placed either locally or globally. Locally, the declaration will only be in scope until the end of the code block, while at the global scope it will apply to the whole source file following its declaration. Keep in mind that importing a namespace into the global scope defeats the main purpose of using namespaces, which is to avoid naming conflicts. Such conflicts, however, are mainly an issue in projects that use several independently developed code libraries. If you want to avoid both typing the fully qualified name and importing the whole namespace, there is a third alternative available. This is to only import the specific members that are needed from the namespace. This is done by declaring one member at a time with the using keyword, followed by the fully qualified namespace member to be imported. Another way to shorten the fully qualified name is to create a namespace alias. The namespace keyword is then used followed by an alias name, to which the fully qualified namespace is assigned. This alias can then be used instead of the namespace qualifier that it represents. Note that both the namespace member imports and the namespace aliases may be declared both globally and locally. Aliases can also be created for types. A type alias is defined using the typedef keyword, followed by the type and the alias. The alias can then be used as a synonym for the specified type. Typedefine does not only work for existing types, but can also include a definition of a user-defined type, such as a class, struct, union or enum. Typedef aliases are not commonly used since they tend to obfuscate the code. However, if used properly, a type alias can simplify a long or confusing type name. Another function they provide is the ability to change the definition of a type from a single location. Keep in mind that in C++, merely importing a namespace does not provide access to the members included in that namespace. In order to access the namespace members, the prototypes also have to be made available, for example by using the appropriate include directives. Enum is a user-defined type consisting of a fixed list of named constants. In the example shown here, the enumeration type is called color and contains 3 constants, red, green and blue. The color type can be used to create variables that may hold one of these constant values. In order to avoid naming conflicts, the constant can optionally be qualified with the name of the enum. The switch statement provides a good example of when enumerations can be useful. Compared to using ordinary constants, the enumeration has the advantage that it allows the programmer to clearly specify what values a variable should contain. Usually there is no need to know the underlying values that the constants represent, but sometimes it can be useful. By default, the first constant in the enum list has the value 0, and each successive constant is one value higher. These default values can be overridden by assigning values to the constants. The values can be computed, and do not have to be unique. The compiler can implicitly convert an enumeration constant to an integer. However, converting an integer back into an enum variable requires an explicit cast, since this conversion makes it possible to assign a value that is not included in the enum's list of constants. An enum does not have to be declared globally. It can also be placed within a class, as a class member, or locally within a function. The preprocessor is a program invoked by the compiler, which modifies the source code before the actual compilation takes place. This modification is done according to the preprocessor directives that are included in the source files. The directives are easily distinguished from normal programming code, in that they all start with the hash sign. They must always appear as the first non-white space character on a line. The include directive inserts the contents of a file into the current source file. If the file name is enclosed between angle brackets, the compiler will search for the file in the default directory, where it is configured to look for the standard header files. If instead the file name is specified between double quotes, the compiler will first search for the file in the same directory as the source file, and in case it is not there it will then search among the standard header files. Double quotes can also be used to specify an absolute or relative path to the file. The quoted form of include is normally used for programmer-defined headers, while the angle bracket form is used for standard library headers. Another important directive is define, which is used to create macros. After the directive, the name of the macro is specified, followed by what it will be replaced by. The preprocessor will go through and change any occurrences of the macro, with whatever comes after it in its definition, until the end of the line. By convention, macros should be named in uppercase letters, with each word separated by an underscore. That way they are easy to spot when reading the source code. A defined directive should not be used to directly override a previously defined macro. Doing so will give a compiler warning. In order to change a macro it first needs to be undefined, using the undefined directive before it is redefined. Note that attempting to undefine a macro that is not currently defined will not generate a warning. A macro can be made to take arguments. This allows them to define compile time functions. For example, the macro function here evaluates to the largest of its two arguments. The macro function is called just as if it was a regular C++ function. Keep in mind that for this kind of function to work, the arguments must be known at compile time. To break a macro function across several lines, the / character can be used. This would escape the new line character that marks the end of a preprocessor directive. Note that there mustn't be any white space after the /. Although defined directives can be powerful, they tend to make the code more difficult to read and debug. Macros should therefore only be used when they are absolutely necessary. C++ code, such as constant variables, enums, and inline functions can often accomplish the same goal more efficiently and safely than defined directives can. The directives used for conditional compilation can include or exclude part of the source code if a certain condition is met. First, there is the if and end if directives, which specifies a section of code that will only be included if the condition after the if directive is true. Note that this condition must evaluate to a constant expression. Just as with the C++ if statement, any number of else if directives, and one final else directive, can be included. Sometimes, a section of code should only be compiled if a certain macro has been defined, irrespective of its value. For this purpose two special operators can be used, defined and not defined. The same effect can also be achieved using the directives, if defined and if not defined, respectively. For instance, the if defined section is only compiled if the specified macro has been previously defined. Note that a macro is considered defined even if it has not been given a value. When the error directive is encountered, the compilation is aborted. This directive can be useful, for example, to determine whether or not a certain line of code is being compiled. It can optionally take a parameter that specifies the description of the generated error. Another standard directive is line, which can be used to change the line number that is displayed when an error occurs during compilation. Following this directive, the line number will as normal be increased by 1 for each successive line. The directive can take an optional string parameter, which sets the file name that will be shown when an error occurs. The last standard directive is pragma, or pragmatic information. This directive is used to specify options to the compiler. For example, pragma message can be used to have the compiler output a string to the build window. Another argument for this directive is warning, which changes how the compiler handles warnings.